Okay, today we're going to look at how to do something called completing a square. Completing a square is used when you want to write something as a perfect square, meaning you want to write it as something being squared. So I'm going to write as a parentheses being squared. We can use this when we're trying to solve, say, quadratic equations that we can't factor. So say we have something like the first problem over here. X squared plus 6x minus 1 equals 0. I can't factor that. So I'm going to have to see if I can figure out another way to actually solve this. So let's leave that to the side real quick and go over and look at some ones that are already set up as perfect squares. So if I look over here at x squared equals 4 and x squared equals 7, those are already set up as perfect squares. We have x squared, which is something squared, equaling 4. I can solve that. I could solve x squared equals 4. Well, I could solve that the old way and go ahead and get everything over to one side equals 0. Factor. X squared minus 4 equals 0. So x minus 2, x plus 2 equals 0. So x equals 2 and negative 2. Or I could solve by just taking the square root of both sides. If I take square root of x squared, I get x. If I take square root of 4, I get 2. Notice my answers differ though. When I factored, I had both the positive 2 and the negative 2. When I use the square root, when I take the square root in an equation, I have to account for both the positive and negative answers. We often just write this as plus minus the number, so plus or minus 2. So let's try with the other one, the x squared equals 7. This one, if I moved over the 7 to try to factor it, wouldn't work as easily. So let's just go ahead and take square root of both sides, mainly because 7 is not a perfect square. Okay, so I'm going to take square root of x squared, I'm going to get x. Take square root of 7, I get square root of 7. Can't simplify it, so it just stays. And because I have to have both the positive and negative roots, I'm going to write plus and minus 7. Sorry, plus and minus square root of 7. Okay, let's try it with other things squared. So x squared equals 4 was already in that set. X plus 3 whole thing squared equals 6 is in that set. And x minus 5 whole thing squared equals 9 is set up the same way. It's already a perfect square. So if I solve the first one, x plus 3 whole thing squared equals 6. Again, I could FOIL it out, try to pull the 6 over. But since I know radicals, it'd be easier for me just to take square root of both sides. If I take square root of that left side, square root and square cancel out. If I take square root of the right side, I just get square root of 6. Again, throw in that plus or minus to account for both the positive and negative roots. Okay, continue solving for x. I'm going to subtract the 3 over. Get minus 3 plus or minus square root of 6. Usually the plus or minus is used as the middle terms. You can see it. It's not wrong if you write plus or minus square root of 6 minus 3. But just traditionally, the plus or minus is the middle term. So you'll see that minus 3 plus or minus square root of 6 more often. Okay, let's try it with the next one. X minus 5 whole thing squared equals 9. If I take square root of the x minus 5 whole thing squared, the square and square root will cancel out. I'll get x minus 5. If I take square root of 9, I'm going to get 3. Again, don't forget the plus or minus. So I'm going to get x equals 5 plus or minus 3. And this I can actually get two answers out of. This is x equals 5 plus 3, so that'd be 8. And x equals 5 minus 3, so that'd be 2. Since I have two real answers out of this, real meaning they don't have a radical. The other ones are real, but they're irrational. So I guess because I have two rational answers out of this means that this one actually would have been factorable. Even though it would have been factorable, though, because it was written like that, it was probably still easier to solve by just taking the square root. Okay, so how does this help us with our actual problem? X squared plus 6x minus 1. We're going to go back to here. Well, I now know that if I could somehow get it so that left side is written as a perfect square equaling a number, then I could solve it. Same way I did the x plus 3 equals 6 and the x minus 5 equals 9, whole thing squared. Keep forgetting to say that. So let's see if I can rewrite it so I get that left side to be a perfect square. So first thing I'm going to do is get it to equal a number. I'm going to move that minus 1 over and get x squared plus 6x equals 1. I left a huge space here. I have x squared plus 6x, huge space, equals 1. And the reason I did that is because I want to factor this into two binomials. Whenever we're factoring into two binomials, we usually have this quadratic, and it usually has the 3 terms. When we're factoring it, we know the first term of the binomial, in this case, because it's an x squared, is going to be x and x. Okay, and usually our second term of the binomials multiplies to give us that blank space, that space I left, and adds to give us that middle space. Well, we don't have a number in that blank space, so that's not really going to help us too much. But I do know that these numbers, these second terms, have to be the exact same. I know that because I need my binomial to be the exact same so I can rewrite it as that binomial squared. Okay, so what's the only same number that adds to 6? Well, 3 plus 3 adds to 6. 3 and 3 are same number. So if I could factor this to x plus 3, then I could rewrite it as x plus 3 whole thing squared. And I could solve it the same way I did in one of the previous problems with the x plus 3 whole thing squared. Okay, so currently, this trinomial with that blank space is not factorable to the x plus 3. I need to add whatever that third term is. Well, I know that that third term I get by multiplying the two numbers together, so 3 times 3 gives me a plus 9. If I add plus 9 on one side, I'm going to add plus 9 on the other side. That way my equation still works. So I'm going to check it. X squared plus 6x plus 9, does that factor to x plus 3? It does. Okay, and then x plus 3 I can rewrite as x plus 3 whole thing squared. So I got to where I wanted. On the right side, I have 1 plus 9, so 10. Now I can solve this, take square root of both sides. I'll get x plus 3 equals square root of 10. I don't know and I can't simplify, so I'm going to say square root of 10, making sure I put the plus or minus, and continue solving. X equals minus 3 plus or minus square root of 10. Okay, let's do this a few more times, see if it makes a little bit more sense. So let's go to the next one. Say I have x squared minus 10x minus 3 equals 0. Again, this isn't factorable. Just looking at it, I can't find things that multiply negative 3 add to negative 10. So I'm going to try to solve it by rewriting that left side so I have the exact same binomial so I can rewrite it as that binomial squared. Okay, so first I'm going to do is move my number over. So I'm going to have x squared minus 10x equals 3. Okay, so I want to try to factor this now. Currently, it's not factorable into the two binomials because I have this blank space right here. But I know my first term has to be x and x. That would give me the x squared. My second term should multiply that blank space and add to that minus 10. And since I want to write it as the binomial squared, it's got to be the exact same number. So what's the only same number that adds to 10? 5 and 5. Since it adds to a negative 10, minus 5 and minus 5. Okay, so if I look at the trinomial, currently it's not factorable to this. I need something in that blank space. So minus 5 times minus 5 is 25, positive 25. If I add that on one side, I got to add it to the other. Now I want to check. X squared minus 10x plus 25, is that factorable to x minus 5? It is. And therefore I can rewrite it as x minus 5 whole thing squared. On the right side, I'll have 28. I'm going to take square root of both sides, so I'll get x minus 5 equals square root of 28. Don't forget to put the plus or minus in front. Okay, so real quick, square root of 28 can be simplified. I can rewrite that as square root of 4, square root of 7. So I actually have x minus 5 equals plus or minus square root of 4 is 2, so 2 square root of 7. Continue solving. X equals 5 plus or minus 2 square root of 7. And that's it. I'm done. Okay, let's try 2 more. Say I have x squared plus 12x plus 4. Again, I want to solve it by completing a square. That means I want to rewrite it, so I have on the left side the exact same binomial, so I can write it as that binomial squared. So first thing I'm going to do is move my plus 4 over. So x squared plus 12x equals minus 4. Okay, so on my left side, if I factor that, I'm going to have an x and x. I'm looking for two numbers that multiply that blank space and add to that plus 12. It's got to be the same numbers so I can write it as something squared. So the only numbers that are going to work is plus 6 and plus 6. So I'm going to have x plus 6 whole thing squared on my left side, hopefully. Currently, this is not factorable to it. I have x squared plus 12x. I need to add in something. So 6 times 6 is 36. If I do that to one side, I'm going to do it to the other. And I'm going to check. X squared plus 12x plus 36. Yes, 6 times 6 multiplies, give me 36, adds to 12. So it does factor to x plus 6, x plus 6. And I can rewrite as x plus 6 whole thing squared. On the right side, I'll have 32. Take square root of both sides. X plus 6 equals square root of 32. Don't forget to throw in the plus or minus. Square root of 32, I can rewrite. Square root of 16, square root of 2. So I'm going to have x plus 6 equals plus or minus 4 square root of 2. And x equals minus 6 plus or minus 4 square root of 2. And that's it. Let's try one last one of this type. So if I have x squared minus 8x minus 2 equals 0. Go ahead and see if you can kind of follow along. So first thing I'm going to do, hopefully you all move the minus 2 over. So x squared minus 8x blank space equals 2. I'm going to try to factor it into a binomial that I can rewrite as binomial squared. So first terms are going to be x and x. Second term should multiply the blank space and add to the minus 8. Only same number that adds minus 8 is 4 and 4. Minus, so it has to be minus 4 and minus 4. Currently, not factorable to that. I need to add in what minus 4 times minus 4 is, so plus 16. So I'm going to check. X squared minus 8x plus 16, that does factor to x minus 4. So I can rewrite it as x minus 4 whole thing squared. On the right side, 2 plus 16 is 18. So I'll get x minus 4, take square root of both sides, plus or minus square root of 18, which 18 is the square root of 9 and the square root of 2. So I'm going to get x minus 4 equals plus or minus 3 square root of 2. And add my 4 over. X equals 4 plus or minus 3 square root of 2. And done. Real quick, something to notice is when I had it being x squared plus 6x, I divided that 6 by 2 to get my 3 and 3 basically. X squared minus 10x, I divided the 10 by 2 to get the minus 5 and minus 5. X squared plus 12x, I divided the 12 by 2 to get the 6 and 6. And x squared minus 8x, I divided the 8 by 2 to get the minus 4 and minus 4. If I'm looking for the same number that adds to something, it's always going to be half of it. If I'm looking for the same number that adds to 40, well, it has to be 20 plus 20. If I'm looking for the same number that adds to 72, it's going to be 36 plus 36. So whenever I'm looking for this number, the number that is the second term in your binomials, it always ends up being half of your middle. So whatever you're trying to add it to. And kind of a shortcut that's going to help us in the next section.